Welcome, everybody. We're going to be working on our Module 5 today. But as I just forewarned the class, I have some preliminary topics I want to talk about. Our big uh, topic to start Module 5 is dictionaries. And dictionaries is just another data structure that we're going to look at. But as I was kind of, thinking through some of the assignments and stuff that we have left, and um, are there any like major language features that we're kind of skipping over that maybe we should really be talking about, approaches we should talk about. So I kind of want to arm you with a little bit more information. We're not really doing assignments or labs around this information, but I think it's really quite helpful to understand these two approaches that we're about to talk about. The first one I do want to talk about is this thought, and I was just mentioning it before I hit that record button, that whenever we get a program and we're asking a whole series of if, else, if questions where we're testing a number of conditions before we run some code, those that have experience in other languages immediately go, wow, we're doing so many else ifs. What if we just use a switch case statement like I do in Java or JavaScript or C# or whatever? And what I let you guys know is up until not that long ago, I forget which version of Python first included it. Maybe it was Python 3.9 or 3.10 or something like that, where they added what they call a match case statement. I think that's available on W3 schools. In fact, Python match case. All right, so you see, I'm just searching it, and I'm hoping that we end up on W3 schools, and of course not. But you know what? Let's just go to this thing that I'm just randomly pulling up here, and I'm just going to show you what this looks like. So you could replace an if, else if with an approach like this one, if you so choose. Now, I'm going to say that when I do this in other languages, if I'm in other languages, keep in mind we call this switch case instead of match case. But basically, the way that it works is instead of running an if statement, and then if you're always doing something like what we're doing here, which is we're checking to see if the choice on all of these is equal to a certain number, and then we execute code relative to it. That's the type of situation where a match statement works best. So in other words, we're looking to match a certain value, typically a number, but it could be a word. And then when we find that value, we execute the code. Now, think about this. If you have like 4, 5, 6 else ifs, that's not a big deal. It's not really that many to contend with. But what if you were writing a program that, for example, a user went to a screen, hit a drop down, and there was a list of all 50 states or all the countries on planet Earth or something like that, where it's like 50 or 100 or 200 items that you're trying to run an else if on. A match case statement actually becomes a lot more efficient to execute in those situations, and is often preferred by programmers as a really useful tool for those types of situations. So this is an alternate. I'm not going to code on this or do a demo. This is the low level example, by the way. It actually can go much farther, so they have like you deal with letters. You can use a blank to kind of deal with all the other situations. And there's variations that go on and on and on. Okay. So that's the match case statement. I just want to put it on your radar. So if you ever get into the situation, you're writing like 50 else ifs, you might want to consider a match case statement instead. Documentation is out there. I'm sure it's on W3 schools if we looked. The other thing that I wanted to talk about is this approach of running programs the way that we've been doing it. And it's getting a little weird now because we are doing imports and we have class definitions built in, and normally I would put that in a separate file. We've already talked about that. Then we go ahead and we define a bunch of functions, and then way at the bottom we do the big while loop that keeps the whole program running. Okay, great. That's a wonderful approach. But what I'm going to do here is I'm going to show you what might be a better approach, and I'm just going to create a program called sample. And what is very typical if you learn a different language, once again, I'm going to look towards the C style languages of C# and and Java, right? And anybody that's coded in those languages realizes that, like, when I write a Java program, if I want the program to run, the code that I want to run has to go inside what we call the main method, right? And so we can mimic that in Python. So we can create a function called main, right? And then I'll just put in a pass statement for right now. But down at the very bottom of the program somewhere, I call it to run. And for example, with the code that we've been building so far, I would just put my big while loop here, right, with the menu and the selection pieces and all that. And then all my functions would get listed down below. And all of the program control then resides in the main method. You know, and unlike Java or C Sharp, where it would run automatically, in Python, you have to call it to run. But what's really convenient about this is instead of looking at the bottom of your program to see where the major runtime stuff is, now all of that's at the top. So I could very quickly restructure this program to run with a main method by just putting this while statement. I could just indent it, put it inside the main method, call the main method at the bottom, and it would still operate the same. The beauty of using the main method, though, especially when you put it up at the top, you can just do basically simple function calls. For example, this while loop that runs the whole program could be a separate function. It could be get menu, for example, right? And so the main function call might just be get menu, would call this in, this calls everything else, and that's it. So you know, like the crux of the program then gets stripped down. Now, the approach that really we're trying to enforce here is that when you start adding a ton of code, and right now, you know, we have like 60 lines of code, not a lot, right? But you start writing a program and you get to like 2, 3, 4, 5,000 lines of code, and it's a lot more difficult to manage. Now you start thinking about like, well, maybe this can go in a separate file. Maybe I could move all these functions down here, put all this stuff in a function, call it from a main method. And that way you can look at your main method, which is a real high level control panel, if you will, for running your program, right? And so this is a really common approach when you start writing code that has a lot of lines of code in it. Right now, we're not really at that point, but you could see how it could get to that point without a lot of, you know, doing, right? All you have to do is imagine more functionality for your program, and oh my God, you can have 1,000 lines of code in the blink of an eye. All right, so that's kind of my little sample there. So a main method to run all the code. You would define all your other functions here. You would probably take that big while loop and put that in a function and call that function. And the main method steers the whole thing. It's like the cockpit of an airplane, right? All the controls are right there. Everything we do is right there, right? And if you've coded in Java or C Sharp, you know what I'm talking about. It's not very difficult to conceptualize. It's not something that we're pushing here as an agenda item for this class, but as you do move forward and do more advanced forms of Python coding, that becomes a technique that you'll want to employ ultimately. The match case statement is a very useful one. And the fact that it's pretty brand new, I think is really kind of cool, right? It shows that Python is evolving, that programmers are switching to the language and going, hey, where's your switch case statement? Why don't you have one of those? And the main method approach is the same thing. It's like people comfortable with C-style programming that are used to a main method or a start method or whatever, and are missing it and going like, why don't we do that in Python? Well, you can. It's just a simulation, right? It's not required to run the code. Right? So that's my little soapboxy thing there. I'm going to go ahead and do a little file attaching here. So we are going to be working in module 5 here. I've pre-created a labs folder. So I'm selecting that one. This is where we're going to do all our code. And I'm going to kill the welcome screen, go back to our class structure here and start reading up on dictionaries, which is our first major lecture topic here for the night. And a dictionary, I just want to say this up front before I even click through to W3 schools. A dictionary is another type of data structure. So far, we've been using lists, right? So I'm just going to kind of quickly, like, I guess I already closed it, but we were doing lists of various objects, and we were creating classes, right, where we were taking those objects and putting them in a list, right? A dictionary is a different type of data structure. It's similar, and you'll notice very quickly, it looks like something you might already know. So if you've already coded, right? So once again, those with experience in coding might very quickly go, that looks like JSON, or that looks like an associative array from Java, or that looks like a dictionary from C#, right? In C# we call it the same thing. We call it a dictionary. Basically what a dictionary is and how it's different than a list is a couple different things. The first thing is we encapsulate the dictionary in curly brackets instead of square brackets. That's how we know it's a dictionary here. The other aspect is that when we're looking at the code, notice that we're still taking individual items. So I'm highlighting these entire things here because these are all individual items in the dictionary. They're all separated by commas. However, there is no index number for the contents of the dictionary. A dictionary is ordered not by its index position, it's ordered by the key, right? So the stuff on the left side of the colon is the key. The stuff on the right side of the colon is the value. And so what we're establishing is an approach that we call a key value pair. That's the data structure. So think about how it, like a real dictionary works. If you look up a word, well, you look up the word. The word is the key, right? And then you find it alphabetically in the dictionary. And then there's a definition next to it. That's the value. So we have a key and a value, right? So it's not ordered by what position it sits in. So I can't say this dictionary position 0 or index 0. There is no such thing. The way I would access Ford, which is really the value, is I would look up the key brand, and then it would find the value Ford, right? Like I look up the word in the dictionary and it gives me the definition. So key, value. The other thing you're going to notice is two of these examples, the key's a word and the value is a word, but the last one's got a key is a word and a number is the value. And not to blow your mind, but you can do it the other way around too. You can have the number be the key and the text be the value, or a number be the key and the number be the value. Or, and to get even weirder about this, the key and the values can actually be complex objects too. So like in the value area, I could put class structures and objects and other complicated data structures. So for example, I could have a key value pair where the value is a list of objects. I talk about like kind of getting deep here, right? Python is that kind of flexible. It allows for all of that weirdness. But the key is when I'm looking up a value, I use the key to find the value. No index numbers. So that's kind of the crux of how it works. So now let's look at like their explanation here. It says dictionaries are used to store data values in key value pairs. A dictionary is a collection which is ordered, notice the asterisk, changeable, and should say does not allow duplicates. So for example, I can't say brand Ford and then say brand Ford again once, right? And think about it, this is how a dictionary works too. I can't have two different definitions for a word. They're all part of the same definition, right? All right, so ordered, but it's not ordered by number, it's ordered by the keys. The contents are changeable, so I can add to it, remove it, change the values, and I cannot duplicate values. So those are the kind of the big takeaways. We use curly brackets to do it. And this approach, this key value pair approach, let's a little strange. That was very spammy. You guys picked that up? Very, very weird. Okay. That was W3 Schools doing that, by the way. I have it captured on video for all to see. All right. So um, the point of this is, right, this curly bracket approach and key value pairs is essentially the same approach we use in a lot of different languages. Most notably, and the reason I bring this one up is the JavaScript object notation looks exactly like what I have highlighted. It's curly brackets, it's key value pairs, separated by commas. And this has become in many, especially online applications and mobile apps and things like that, kind of the number one transmission format for data these days. Why it's useful is because this information travels with its description. So for example, when I look at this, having never seen the data before, I'm like, oh, they must be talking about a car. I can tell just because. All right, now I'm getting a little freaked out here. All right, let me pause my video here. This is not, people have to pay the bills somehow, I suppose. All right, so this is a really useful data structure, and we can kind of go down the rabbit hole here. This is just a very simple one, but once again, the description travels with the value. So when you look at a value, you know what you're talking about, right? And this is very useful. So the brand is Ford, the model is Mustang, and the year is 1964. Clearly, I'm talking about a car. If I had a different kind of data structure, like a list, and I just saw Ford Mustang 1964, I could probably make that guess. But what if it was more esoteric data and it was just numbers and you had no idea? Maybe it was like age, weight, and height, but didn't travel with the key, so you wouldn't know what those numbers were about, right? So this is one of the reasons why this is kind of popular. Very often, data like this comes from a database or tabular information, like a table with rows and column headers. So like this would be the column header, right? These would be the column headers, and this would be the information in one row in the database table or spreadsheet or data structure, right? And then this structure could repeat. So I could have a dictionary filled with a collection of key value pairs of different cars. So the brand, model, and year might repeat. So that's kind of the point. Now, here's where it gets a little weird. So if I want to take that dictionary and print it, you just call it by name, put it in a print statement, and it'll come out on screen. But if I want to print a particular value, and this is where it gets kind of interesting. When we were doing a list, I would put the index number or the position of the item in the list here, and then it would print out that piece of information. Here, I'm saying in square brackets to print out whatever value I have in the key called brand, and it prints out Ford. So if I change this to, model and run it, it's going to output Mustang eventually. There it is, right? And then you can repeat that. So you can use the key to access the value, right? Pretty simplistic stuff, really, just to kind of drive home the concept. Things are changeable, right? So if you do something weird like this, so okay, ordered or unordered, we say that they're ordered, they have a defined order, and that will not change. However, you're not finding it by the order, right? You're finding it by however it was structured originally. And it's not necessarily alphabetical. It doesn't go in there alphabetically. So that's, I think, pretty useful. The other thing is if you take a key and you assign its value twice, which value sticks? Yeah. The second one, and this is true of all coding, it reads top down. So it'll do the first one, it'll put 1964 in year, and then it'll put 2020 in year, and that's the one that ends up sticking, right? So you see, so you can use a key again. Not that it's really a good idea. Okay, that's the point there. So that's what would happen. You can also run the length function on the dictionary. So if you want to figure out how many items are in the dictionary, just run the length function, len. Greg?
Yeah, sorry about that. Uh, Back up under uh, the dictionary does not duplicate values. If I were going to use if I were going to say brand Chevy model Camaro, year 1964, and show that, would I show that with a like a this dictionary two, or would say, would it be better to show it with a this dictionary brand one, brand two, brand three, model one, model two, model three, that kind of
What,
structure?
what the answer is, you then form a dictionary of dictionaries. Okay, so like we do with a list, we were gonna have like a list containing other lists, or you can
Ah,
have a
okay.
dictionary that contains lists. And really what the approach would be is I would take all of this data, put it in a set of curly brackets, put a comma after it, new set of curly brackets with the same data fields again.
Okay. All right. Cool.
That would be the approach. So dictionary inside of a dictionary, basically. Here's a little bit of a ramp up on the thing that you're talking about, right? So here's, for example, um, you know, we start with text and numbers, but truth is the key value pairs can be anything, right? And it would be weird to put a Boolean as a key, but a value can certainly be a Boolean. A value can certainly be a number or a floating point number. And a value really can be just about any data structure or type of object that exists in Python. In this case, we have a list as the value for colors, because maybe it's all of those colors. This is where it gets a little weird, right? All right. We also have the type function. So if I run the type function, it tells me what kind of thing it is, and it'll tell you that it's a dictionary and that it's a class. So dictionaries are a type of class. Um, they also have a constructor function, so you can build a dictionary by doing this. And this is a little weird, right? But I can define the keys and assign the values like I do like regular variables. That's kind of an interesting approach. I will say that I prefer this approach because I'm more comfortable because of like working with JSON and JavaScript and dictionaries in other languages. But Python does allow this. But be mindful of the fact that it's a truncated constructor. It's not the whole word dictionary, it's just DICT. And then key, and then you assign a variable. Key, assign a variable. Key, assign a variable. Um, Dictionaries are part of a collection of different data structures, right? And we've learned so far about lists. We've talked a little bit about tuples, but tuples are basically like lists with parentheses. And you guys remember what their main feature is? A tuple is like a list. It works exactly the same, except you can't change its contents. You can't add or delete any of it. And the big one with that is, well, then why do you have it? Is because often tuples are faster for data processing because the information can't be changed. So it doesn't require as much memory space for really large data sets. So right now we're learning about dictionary. And here's the next thing. There's also a thing called sets, right? Which is weirder. That's coming, right? Let's worry about dictionaries for right now. All right. That's enough to kind of get us started with that stuff. But we do have another topic here, which I think. All right, so this is the items function that works on top of it, or items method technically. Um, so okay, so there's that weird effect again. Now I'm starting to get a little concerned. All right, so the items method for a dictionary is just very simply appended to whatever the dictionary list name is. And I want you to take a look at what's happening here. running a function and it's going to store it in X. So we're going to, whatever its output is, it's going to end up in this variable called X. So we're basically going to take this complex structure, and I want you to see that it kind of goes off the edge of the screen here, right? There's the whole thing. So we can take it, and notice how it kind of gets put in here. It kind of like breaks it down into individual things, sort of like a list. It ends up in square brackets, and it's all contained inside this one character variable. But it still has all the features of the dictionary that travel with it. And this is a really weird kind of thing, once again, with Python, that Python allows for this kind of stuff, that I can take this complex data structure, stick it into a much more simpler definition, and then utilize that simple definition to do much more powerful things. And this is, yeah, you could potentially do that, Greg. You could parse it into a database table for sure, right? That is kind of one of those things that you do. So for example, if I take car.items, we put it in X, right? And then I change the car year to 2018 and I print X, that data change will follow, right? So even though I'm storing it here, and seemingly I'm changing this other object, and this is a really important thing, takeaway here, folks, right? I have named this a certain way, and it's this whole data structure that has all this information in it. Then I'm taking it and I'm putting it in a variable called X, and I'm changing the original object's one value, but then when I print X, that follows. That makes no sense. That is not how normal variables work. But it's telling you a very important thing about this language. It's telling you that when I create X, it's still referring back to the original. So if I change the original, the copies that's stored here is still affecting the original. This is a bizarre feature, right? So this is what we call referencing things in memory. We still have one object in memory we're referencing, a complex one. And when I change the one, it changes the other ones that are referring to it. That's the takeaway, right? If that sounds like, like a different language to you, well, it kind of is. All right, so that's going to be useful for us for doing a little bit of work. So I need to sign back into Canvas here apparently because I got bumped out with the change. All right, so sorry about that. So I have to like re-navigate back to where we were. But now we're ready to do the lab. All right, so what we're going to do is we're going to start by creating a dictionary for county populations in Wisconsin. So the key is going to be the county name, and the value is going to be the population. That's a logical correlation, right? So what we want to do is print the index of Milwaukee. We'll add some other counties. We'll update Milwaukee rounding to the nearest 100,000. We'll remove Racine, and we'll use the items method and for loop to print out the counties and populations. Okay, so if you're wondering why the items thing, it does become helpful in doing output. All right, so let's work on building all these little pieces here. First things first. Let's go back into Visual Studio Code. I'm already in the correct folder, and I'm going to create a new file, and I'm just going to call this kind of like the generic, like module 5 lab1.py. And then I'm going to paste in useful information that I just happen to have as comments here in my sample file. So just talking about dictionaries and what they do, they basically hold key value pairs. Keys need to be unique. Keys and values can really be any data type. Values can be complex types like a list or an object or a class or what have you. All right, so then we're going to create a dictionary. So I have one pre-prepared, right? And once again, we're just going to use a simple variable name and a set of curly brackets to open and close. I'm kind of using the same format I did for lists, right? So I I start with the two curly brackets. And by the way, if I just wanted to declare an empty dictionary, I just give it a variable name equals empty curly brackets. In this case, I'm pre-populating it. The format is already given. The format is key value. So I have 4 counties here from Wisconsin with their populations. You have Milwaukee, Dane, Brown, and Racine County. You can take your time and type that in. All right. The next thing I kind of had as a little note here, I got a lot of little comments in my sample code. Dictionaries use the key as the index, right, or the search piece, right? So if I want to get the population for the county of Milwaukee, I would just simply say print county populations, and inside the square brackets, instead of an index number, the key. So I'm looking up Milwaukee, and that will run. So I'm just going to run it, and we'll just take a look here. Of course, I'll move that out of the way, right? But you can see it put the population up on the screen. I'm going to keep adding to this, so I'll keep that up on the screen. My next comment was this. So we can use the assignment operator to update values. Very simple, right? So if I want to change the county population of Milwaukee to be 1 million, I mean, we're just shy of 1 million, right? Like 60,000 to go. I just use an equal sign. Now, what is that changing in the data? It's changing the value assigned to the key Milwaukee. I'm not changing the key, I'm changing the value. Then, of course, let's prove that it changed, right? So we'll just add the print statement back and print it again. So here comes the run. So first it was 939,123, and now it's 1 million. Does anybody know what the city of Milwaukee population is? That's kind of an interesting one. I just passed the sign today because I went to Woodman's in Oak Creek and drove back home. And right when I come back into Milwaukee, it's like 577,000. Right. And this is, sideline. When I was a child, Milwaukee's population was like 750 or 70,000. There's like 200,000 more people in the city. Where did all those people go? They're living out by you guys now, is where they were, right? All right, let's keep adding to this. All right, so here's my next comment. If you want, I should use proper English, to add, just assign a new key and value. So if you want to add, I should say a new key value pair is what I should say. Just assign a new key and value. So for example, if I want to do the one county that they wanted us to do, which was Outgami, that one's not in the list, right? That key's not in the list, right? Let's take a look. Yep, not in the list. I'm going to declare one, like I do a variable, and give it a value. And then, of course, I can output that. If we run it, there you go. It's captured. But keep in mind, I can just print, what's the name of our counties? What are we calling? County populations. Yeah, county populations right there. So I can, output all of them just so you guys can see that it is being captured, right? So I did add a new key value pair. I'm going to remove that for right now. Yeah, actually, I'll tell you what. It's surprising to me how like my brain gets into like the stream. And I did the same thing last year. And this is what I said after it. Primitive output, but useful for troubleshooting. So you can actually see your list. And actually, not a list, a dictionary. How do I know it's a dictionary? Curly brackets. If I want to remove one of the items from the dictionary, we can call in our friend pop. So we were told to remove Racine. So I just pop Racine out. Sorry, Racine, you're gone. And then, of course, we'll do the simple print approach again. We'll just print the whole dictionary on the screen. And that way we can prove that it's gone. So when I run it, now you see Milwaukee, Dane, Brown, Outgami, Racine is gone. Next thing that I have here is we were asked to run a loop. And this is, all right, this one I'm going to type out manually because I think it's worth explaining. Because normally, think about this, when we're stepping through a list, it's a list of individual little pieces of information. And we know how those are ordered. Those are ordered with numbers, right? So normally, I might have like 3 pieces of information. Or if I have a list that maybe, I don't know, has a certain number of items in it and I want to iterate with a loop through each item in the list, I first hit first item, second item, and I just keep going, and the for loop does it automatically. But now I'm dealing with a key and a value, right? So this is where it gets weird. So I'm going to say for county, comma, population. And what I'm doing is I'm saying I want the key and I want the value when I iterate, not just the value, right? So that's a list just has a value in a position. This has a key and a value. Now, I want to pull back both. So for the county and the population in county populations in our dictionary, and here's where the items function comes in. So I want to iterate through the items, and that's an S, items, there we go. So that'll take those things, put them into a list type structure, and now I can iterate with the key values, both coming up on the screen. I have a simple print statement that will output it. Here's the print statement, and your colon here though. Right, so then I'm just going to output the county. So it'll say Milwaukee County, pipe, population, 1 million, or whatever the last version was. And I want you to notice there's a comma at the end. Because it's going to repeat over and over again. All right, so let's just run this. We'll see what the output is. Here's the run. So it did all the maneuvers, and then it iterated through the list, Milwaukee County, with the change, right? Dane County, Brown County, Outgami, that's how you say it.
What does the comma after the colon do again for the population? Like
Comma
in the
after
print?
colon. This is actually a print formatting command. So like if you remember, like when we do dollar amounts, we do 2F for 2 decimal places for floating point number. The comma here is basically saying when you're outputting the number, put commas in between each 3 numbers. So that's how we get these commas. Sure.
Okay, thank you.
You're welcome. Right. So if you guys are wondering, there's one of those tricks. All right. Everybody get it to work okay? All right. Folks, we're going to pause here, and we are going to take another break. All right, we're back from break, and as I was just saying, I was like tidying up my tabs, and I was just about to close this tab because I didn't think we needed it anymore. But when we looked at the items method for dictionary, just so we're clear on what it does, it returns a view object that contains key value pairs of the dictionary as tuples in a list, right? So when we do the output, right, and I just want to show you what makes it a tuple. So This makes it a list, the square brackets, but it's a list of tuples. So the key value pairs travel inside of parentheses. And why that's important to know, right? So this is an efficiency thing. Um, this is really useful for doing output, but not useful for changing the items, right? Because tuples can't be changed, but they're super efficient for data processing and putting things on the screen, right? So that's what we're kind of building. So it's like one structure inside of another structure inside of another. All right. Now I feel like I can close my tabs. All right. I was looking ahead at lab number 2 here, and we already looked at the documentation on dictionaries, but we have one additional lecture topic here. So let's go ahead and look at this one. This is called string join. And basically, this allows us to join all items in a tuple into a string, right? So, not having really worked specifically with tuples a lot here, but tuples are a really important little feature. Remember, they're just like lists, but you can't change the content parentheses on the outside. Otherwise, they essentially work the same. But what this will do for us, right? It takes all the items in an iterable and joins them into one string. So in other words, it will take all of these and put them together. So let's just kind of take a look at this, right? So this is the joining character. That's kind of weird, right? That's a weird one to use. It could be a dash or a space, right? But they're using that so it's really evident. And we're joining whatever's in the tuple and turning it into one long string. In this case, putting it on the screen. Okay, why would that be useful? Well, if I'm like taking like the information for a car, right? I could say Ford or 1964 Ford Mustang. I could join that all together and then output it all in one string. Right? And it makes for a nice output. That's the one practical usage for it. There's not really many more examples here I want to show you. You can also use this on dictionaries. That's kind of the other piece of this. So it works on tuples. It works on dictionaries. So this would basically, once again, do the same thing. But let's look at the difference. What is it actually joining? It's kind of weird, right? It's not joining the values. You guys picking up on that? It's joining the keys on the dictionary. Weird. Okay. Why would you want that? Well, maybe you want to take the keys and output them separately from the values. That's the why, right? So that might be a thing that you want to do. So that's just a really brief little example of how that works. And we're going to kind of leverage that a little bit here as we're kind of working. So what we're going to do is we're going to, it says this lab's a little more complicated and will be expected for the rest of the class, but it's a good look into dictionaries and how they're going to be used. Okay. So we're going to create a dictionary for storing the colors of a flag. The key is going to be a country name. And notice here the value is going to be a list of colors. And this is where this concept really kind of like gets expanded, because I like this as an example, because some countries have a lot of colors on their flags and some countries only have a few colors on their flags, right? Think about that. Yeah, some countries have like 2 colors. Some countries have like 5 colors, so a list is a good value because we can put as many things in there as we want and not just 1 or 2 or a fixed size. All right. So now that we have that, the next part would be, it should ask the user to implement following functionality: list, add, get flag colors by country, and exit. Okay. Kind of pedestrian for us. Now, we've done this a lot, right? Little menus and while loops and all that kind of stuff. So some of this should not feel too intense, right? Because we've done it. Couple of things, as we kind of do this, they have a couple examples of listing the flags, right? So there's like Canada, United States, Mexico, right? Adding a flag, so we'd enter the country, right? Then we'd enter the color, and then when we're all done, they enter an exclamation point. That's our escape character, right? But we would run this in a loop, keep asking them, enter the colors. It's 2 colors, they type 2, then they press exclamation. So that's the thing we have to engineer. Um, and then we can also get flag colors by country. So you prompt and you type in the country name and then it returns the colors. Right? So some slightly more complicated maneuvers here, but if you start thinking about it, we have all the skills, or at least we've learned about all the skills required to do this, and we're going to code it together. So it's not going to be too mysterious as we're doing it. All right, let's jump back over to VSC. Let's create a new lab. Let's call it module 5 lab 2.py. And because we're going to do the menu thing, we should call in our helper file. However, it doesn't exist in our folder. So let's copy it in. So I have a copy here from module 4. So we're going to copy that file. Hopefully I'm looking at the right one. Yep. And we'll move it into the module 5 labs. We'll just paste it in there. So now it's available. And why don't we just make sure that we do our import right away up here at the top. The one that I plan to use is the get int in range because we'll have a menu, so we want to make sure they choose the right number basically. We're also going to pre-populate a list of countries and their colors. So this is my setup here. So I'm going to type this out manually actually, at least to begin with. So I'm going to call it countries colors. This is a dictionary. So I'll start with a pair of curly brackets. I'm going to go in between them, press enter and split them. And now I'll start to list stuff. For example, we can do USA, right? Hopefully we know the colors on that one. And this is going to be in the form of a list. So square brackets, that's an empty list. And then we're going to type in red, comma, white, oops, comma at the end, and then we can add additional countries. So pick whatever countries you want. Doesn't have to be the same ones that I'm doing. These are the ones I used last time. And I used Malta. I used Greece because I knew those colors because I'm Greek, so I had those I know. And then we did St. Lucia last time because they had more than 2 or 3 colors. So they have blue, black, white, and yellow. Does anybody know of a country that has even more colors than that in their flag? So my brain goes to Brazil, right? Because they have that little like planet, and right. All right, yeah, I'm gonna be goofy about this. The flag of Brazil. All right, so we got green, yellow, blue, and white. Right, that's what I'm saying. So there you go. You can add that one to your list if you want one with 4 colors. Tibet. How many colors does Tibet have? The whole rainbow, right? I'm not sure. Okay, fine, I'll look. Right, I have a browser available.
Belize.
Oh yeah, that's a lot of colors. We got red, blue, yellow, green, etc. Maybe orange in there too. Really funny. One of my students over at Gateways from Belize, I was just talking to him yesterday. Oh yeah, that's got a ton of colors in it. Okay, we'll leave it at that's on you. Which flags you pick? Just make sure you get the colors right. Maybe less colors is better. All right, so we have a dictionary of key value pairs. The keys are the country names in text. The values are a list of colors, right? Separated by commas. The last one does not have a comma after it. All right. Like we've done with many of our other programs, let's get a big while loop at the bottom that's going to run this. We'll force it to true. We'll drop in our menu here. So this will be my menu. Notice I got a little title on it and a blank line, a couple blank lines at the top. So it looks kind of okay. Menu choices are tabbed in. I obviously spent more than 2 minutes figuring that out. Probably a little bit of trial and error from last year. Like we did with our previous labs, we will prompt the user for their choice. And oops, looks like an indent broke there. We'll use our get int in range function from our helper file. We're not looking at that, but let's just pull it up on screen. So we send in our prompt and our min and max numbers, and it handles all the errors for us, sends back an integer when it's correct. Right. And I'm doing that for the benefit of anybody that's not aware of our helper file. Watch. All right, now we go through our if else if statements to kind of drive everything, right? And yeah, this is so much like the other stuff that we've done. You could, save yourself some typing and potentially just copy the paste the stuff in. And of course, we have a list of flags. So we're just going to call these one at a time, even though they're not built yet, right? And yeah, they'll underline yellow until we build them. Then we'll do else if choice is equivalent to 2. We will then add a flag. Another else if the choice equals 3. We're gonna, oh gosh, what did I call that last time? Get colors by country, just what it says up there. Let me just type that in. Get colors by country. Oops, gotta fix those parens. And then we'll do our option for number 4, which is to exit. And we'll just do a break, and then we're out of the loop and the program stops. All right, so I have a couple of different things we're going to do here, right? So this is not different than what we've been doing, but the little mechanics of like how we list, how we add, and how we return the information, like we're still working on CRUD operations here, right? Is a little bit different. The mechanics are different, but the approach is essentially the same. We're just working with a different data structure, so it requires a little bit different syntax. That's really kind of the thing. Let's work first with listing the flags. So I'm going to come up here and define a function called list flags, parentheses. Do we need to send anything in? Nope, we don't. But if we're listing them, I want you to think about the approach of like, we're going to iterate through the data structure. We are going to be looking for the key and the value. We want the country name and we want the flag colors. So I'm going to say for country, comma, colors. So we're going to pull both of those pieces back. In the country's colors dictionary, converted into an items list of tuples, right? That's what that does. Because that's easy to iterate through. Great for doing output. And I did a couple different approaches here. So the one approach I tried, and I'm ended up not using this, by the way, is to just print out the country. Right. Well, and this must have been before I added the colors piece to it, just to show what that does. But that's not what we want. We want the country and the color, right? So here's where we use that function to join strings, by the way, and this is how I did it. Right, so I'm going to put in a print command. I am copy pasting it. We'll talk about it after I do that. So we're going to put in the country name, right? A colon, then a comma, and join the colors together. So in other words, when we do the join command, this is the separator between the colors. So the colors will be red, white, blue. It'll be red, comma, space, white, comma, space, blue. That's what that does, the join command. So this is kind of like one singular command. But like the weird join things that we saw in the W3 school examples were like a pound sign and a test word or whatever. Now, these two functions don't exist yet. So why don't we just build their shell, put in a pass command, and run the list and see if that just even works. So we'll define add flag, empty parens, colon, and a pass statement, back to the margin, and then we'll define get colors by country. And same thing, just a pass statement, just so we don't have errors and we can run it. Let's see how the list works. You know, and what we're doing here is we're going to iterate through this dictionary key, a list of colors in the value position, and we'll see how the join command runs it. Control S to save. Here's the runtime. Here's the output screen. See how nice that menu looks, right? I like made sure it all lined up and everything. Right. And you can get really fancy with this stuff if you want. But let's go ahead and hit 1 to list, and notice what it did for us. USA colon red, white, blue, right? So that's the joining piece right there. Looks pretty good, right? Maybe not amazing, but not too bad. Right. If I really wanted to make it look amazing, I could do formatting commands so the country is like right aligned and the colors left aligned, but that's way too ambitious for me right now. That was our sample run. And keep in mind, whenever you're building a program, if you want, you can kind of do the same thing I just did. You can the functions you haven't built yet, just put in that pass statement, get the basic ones to work first, and test one at a time and see if they're working. Right, just a common sense kind of approach. All right, let's build the other pieces now. Let's do add a flag. All right, so let's remove that pass command here. And if we're going to add a flag, somebody's going to, press the number 2, and they have a country in mind, and they have the colors already set to go, right? And hopefully it's not Belize, right? We're not counting the colors in that one. All right, so we would prompt them, right? So we would maybe create a variable called country to hold the country name or the key, and we'll just do an input statement and ask, enter the country name, colon space. We'll capture that text, put it in that variable. Then, because keep in mind here, the values in our dictionary are a list. Let's put a list here. Let's create a list called colors that just exists inside this function, and it's empty right now. And then we'll just prompt the user to keep entering stuff. And if you look at the example that we were given, because we don't know how many colors it's going to be, right? Could be 1, could be 3, could be 10, whatever. That was amusing. So that's got to go into a loop, and we got to give them a way to escape the loop, right? So I'm going to do a while loop here. So I'm going to say while true, so forcing it to run again. We'll do our prompt. We're asking for the color, so we'll say color, and we're going to assign it whatever they're inputting. So here's our input statement, and we'll say enter a color. And if you looked at the example, there's a thing that says something like exclamation to end, right? And then let's do a colon and a space. And I forgot my double quotes all the way through this, by the way, but I think I'm going to use single quotes here for a reason. So I'll put my single quote here at the end, and then I'm going to put double quotes around the exclamation mark, right? So enter exclamation mark to end, right? That's the terminating loop. All right, so let's handle the termination. So if the color they entered is equivalent to an exclamation mark, then we will just break out of the loop, and that if statement's done. So that's our exit out. Otherwise, if they actually type a valid color, we could say color. Okay, so this is where I'm kind of screwing up here. I called my list colors. No, I'm doing okay. So I'm going to append to the list called colors. I'm going to append. What am I going to append? The color they just typed in. Right? If they type the exclamation mark, they would never reach this point, by the way. And then that's the loop. And then we need to take that and enter it into the dictionary. We didn't do that part yet. So we're going to say the country's colored dictionary for the current country that we just typed in, this new country. We're going to assign to that key the value of colors, which is a list of colors. Could be one, could be five, or whatever. Okay, so that's my add a flag. All right. Once again, I'm tempted to test this before I move on. Right. Let's see if this works. Let's not take it on faith. All right. So Control S to save. Here comes the run. Right. Oh, I never exited before, so I got to exit. Now let's run it. Here comes the run. But first, let's list the flags. All right. Looks good. That part works. One thing I don't like about the list, real frankly, is I think I just need a print statement there. Just a blank line would be helpful, by the way. So that'll happen next iteration. But now we want to add a flag. So I'm gonna click back down to the console, type 2, enter the country name, and what was the example that we were looking at? Tibet, right? And what were the colors? Okay, I have to look it up again. Sorry.
I was gonna say, Ty, when you're switching to the windows, I know just be careful with the video recording again.
Oh, it is. Okay. Do you see the task switcher up on screen still?
It disappeared, but it was up there.
Yeah, I don't know why it does that. It only does that when I'm recording with you guys, not at the other school. Let me just try something really quick. I'm going to pause the recording. All right, so it looks like we have, I guess I'm going to call this purple, red, yellow, green, and orange. Okay, remember that list.
Well, right in the description, it's white, yellow, red, and blue. Right in the description there.
White, yellow, red, and blue. All right, Greg, you're tasked with reminding me. All right, because the program's still running. So white, yellow, red, and blue, right? Okay.
And yep, then, that's it.
I want to end, so I'm going to type exclamation. And I'm out. Now I'm going to list again. And it looks like it's stuck. Okay, so we're good. All right. Let's exit out of the program and close the console here. And let's build the last function here, which is get colors by country. Now with this one, I made a couple of notes, and this is kind of interesting because to do this, I want to ask the user which country, right? I could do the asking inside the function, or what I'm tempted to do, and this is what I did last time, is I did the input statement here. I do see that I have a question, so let's field the question first. Alexis?
Yeah, I was just wondering if in the add flag, if it would be a good idea to check and see if they already added that color. So like
you okay, so this is maybe, I see where you're going with it, and I think from an engineering point, that's like the right thing to do. Like, you know, you could put in an if statement to say, hey, if you already typed white, don't type white again. that kind of thing. That's very logical. That might be overthinking it at this point, but if I was to fully build this out, yeah, that would be definitely a thing I would add. The other thing I would
But
probably
there,
add, and you think about this, is does that country already exist? That would be the other question, right?
yeah.
Yeah.
But like there is a way to check in the tuple, like to see what it includes, right? Like I know at least JavaScript and stuff, there's like dot includes, but
Absolutely, right. And
okay.
basically, you just traverse it, and you traverse the list of colors, and just check to see if it contains.
Mhm.
There's actually methods that do exactly
So
that.
basically another for loop or something kind of similar to that.
Precisely, yeah.
Okay.
Would be another for loop, but yeah. And you would do one for the colors, and you would do a different one for the countries. That would be right. And like I said, we might be at this point over engineering it, right? Because we're, our ask is not really that tall. All right. So what I'm doing with this get colors by country is I'm doing my input command here. So the prompt is going to travel from here and get sent as a parameter over to the function. So whatever they type in. So we're going to capture it. And what did I prompt? Did you say enter country name? So enter country name. This is more to show you can do it here in position if you wish, right? You could also prompt in the function, and maybe that would be a good, you could also prompt this in the function rather than send it. And that's kind of a personal choice, right? So that means here we have to receive the country name. So I just called it name. You can call it whatever you wish. You can call country or whatever. And then I just posed this simple if statement here. And I said, if the name is in the country's colors, so if it's in that list, and keep in mind here, when we're looking something up, and I keep saying list when I mean to say dictionary, if the name exists as a key inside here, and Alexis, this is maybe part of the answer for figuring out if you already entered a country, right? Then we can execute this code, right, where we would basically join, right, comma space, the country's colors based on the name. So what this would do is it would look up the country, find its colors, join all the colors together once again, and then output them in the statement. Now, if that doesn't work, right, so that means like we're looking up a country, we're asking it to print out the colors. What if it's not there? Well, then we need an else to handle that, and the else could just be this. So, I mean, you could basically use this code to, confirm your colors or countries in the other action if you wish. It's not really that much code. All right, so this kind of answers that piece now, right? So we have that piece in place. Let's go ahead and save this and run it. Right, so here's the runtime on it. Let's start by listing. Let's add a flag. Let's do Canada. Little Canadian flag colors. We got red, we got white, and that's quite enough colors for those people, for sure. Especially after that hockey game. Did you guys watch that hockey game? Nobody. I happened to be out with my wife at a place, and the game was on TV, and I thought nobody was watching it. And then the U.S. scored a goal, and the whole place like burst out screaming. It was so weird. Like everybody was watching it except for us. All right.
Wait,
So
are you talking about the hockey game?
Yeah, the hockey game.
Okay. Did you see the first 9 seconds of the game?
No, I did not. Only in recap videos in the aftermath.
Okay, there was literally 3 fights in the first 9 seconds of the game
Yeah,
for
I
USA
heard.
versus Canada. Yeah.
Not like there's sour grapes there anywhere, right? Right.
Yeah.
Let's try our new menu option now, which is option number 3. So let's put in Malta. All right, and notice it doesn't output. And then once again, I look at the output and I go, oh, you know what? I should put a blank line in there, whatever. Um, you know, do as you will, right? So we got that. Let's try another one to make sure Canada is working. All right, that's working. So that seems to be working. And now it looks like we can also exit pretty easily. So that completes our second lab here, folks. We
What
are
is
ready to move forward. But questions, yes, please.
yeah? What is the code in the helper file?
What is the code in the helper file? The same code we used before.
Got it.
Yeah.
Oh,
And this is the function that we're using here,
okay.
right? And to do it in range, and that's basically to address all
Right.
of
Right.
our menu options, right? Now, keep in mind, we haven't gotten to the point where we're removing stuff or updating stuff, but that's possible too, right? Right now, we're just listing, adding, and then retrieving particular things from our dictionary when we are prompting it. And as long as the country is there, and I suppose the thing that we didn't try is what happens if the country's not on the list. We should get that message, right? Okay. Let's move on because we still have a couple labs to do here tonight. So let's not waste too much time. And I'm trying to get to the browser here a little more efficiently, and I'm fumbling. All right, let's move on to the next lab here, and I think a video is going to pop up here momentarily, which I'm going to stop. And, on to lab number 3. Now we are going to introduce a new concept here. Once again, for some of you, this might be repeat information, and I apologize for that, but we're going to look at this construct in programming called regular expressions. And this is kind of an interesting one because regular expressions are kind of a universal way to format or ensure that data is being formatted in the correct way for our application so that when people enter information, we can confirm that it's correct before we even process it in our software or add it to our database. And what's neat about regular expressions is it's a universal tool. And I'm struggling for the right language here. I don't know if it's not a language. It's a tool that we use to ensure the data is coming in correctly. And it's a tool that's used by many programming languages. It's not just Python. So we use the same commands if we're writing HTML. We're using the same commands if we're writing C# or Java, or if we're inputting stuff into a database, we even use it there. Jake, question.
So is this basically RegEx? I'm just going to call it. Is this the same concept as RegEx in just regular old Linux?
It is, yes.
Okay.
That's the shortened name for it. RegEx is the, so that is another way that people speak of it, folks, is RegEx. In other words, they take the regular and the X, and they combine it together. They use it as one short phrase because it's so many less syllables to speak than saying regular expressions. You just say regex. But yes, absolutely. And Jake's pointing out a little thing that yes, even on a command line, you can use regular expressions. So if you're asking somebody to type in a number or an uppercase letter and they're not doing it, you can kind of halt the application there to check. So that's kind of like the overview already. I noticed how on W3 they call it regex, right? A regex, or regular expressions, is a sequence of characters that forms a search pattern, and it can be used to check if a string contains the specified search pattern. So for example, if I type in or ask my user to enter their email address, think about how an email address is formatted. An email address has some text, the @ symbol, some text, a period, and then a top level domain. Right. In the old days, it was really easy because there was only 3 or 4 or 5 top level domains like .com, .org, .net, .mil, .gov, .edu. And then that all changed. Now, like Top level domains can be complete words, 2 letters, 3 letters, 4 letters. I mean, oh my God, right? So many different things. But it can save us from a lot of hassles, because think about this: if you're running an application and you can establish a pattern for the incoming data before it hits your application, you're preventing stuff from breaking. And often when we're building applications and capturing data, that data then gets transported into either a data structure like a dictionary or a list or a tuple or a set, or it goes into a database. And all of those structures might have, you know, things in place, and especially a database. Like when you learn how databases operate, when you're feeding information into a database and you're putting it into a field, in databases, unlike Python, they're strongly typed. So if you're expecting information in a certain format and it's not in that format, it breaks your database. It just doesn't work. And that's a no-go for application development. It happens on websites too. You go to a website, you ask somebody for their email address, they type in a phone number, that type of thing. Or how about this? You type in a phone number, right? And then some people type in phone numbers with parentheses around the area code and then dashes in between, or some people get clever and put dots in between their numbers. And then you hit enter or, submit or whatever. And it says, that's not a number. Just type the number. And it's like, what are you talking about? I always put in my dots or my dashes, that kind of, this is what we're talking about, is controlling the input of stuff. When we're adding the RegEx module to our programs, we do have to have an import statement. So this is part of the standard libraries. We bring in the whole module. So we just say import RE, which stands for RegEx, right? So that's all it takes to add the capability to Python programs. So you do the import. And so, for example, and this is not something you have to worry about memorizing, by the way. I've been using regex expressions since I learned how to code. So this is like 30 plus years. And I never went to the trouble of memorizing how they're laid out. Here's the weird part about regex. They make books that are like 3 inches thick that cover what regex does. And I don't think anybody really reads them, right? Everybody Googles what they need. They find the code online, they drop it into their app, and they roll with it, right? And that's how it's going to work here too. In fact, if you look at our module, the regex statement's already constructed, right? Because if I was going to teach you how to write regex expressions, we would be here for a whole nother course. And
Who constructs these? Like, who constructs these when no one wants to do it?
Yeah, well, Shravan, I don't know the exact history of regex, but it goes way, way, way back. And I'm guessing like either 60s or 70s is when it was developed, probably along with Unix and the C programming language. And a lot of the innovations that we have in programming came from those early languages, particularly C, right? And kind of tying it all together, a lot of times when we're importing libraries, even in Python or C# or pick a language, all the work was already done in the old days by all these old programmers. And we just import the same library. We still import the C libraries. Python still uses the C libraries. It's so weird, right? The libraries work. Why rewrite them is kind of the mindset, right? They just write translators so the stuff moves back and forth correctly, but we use the same code. But there are people that are experts in this, and it is a very esoteric few, right? Let's just put it like that.
Yeah. Okay. Thank you.
Yeah, I mean, I know some of the basics for regex, like how to do like capital letters, lowercase, numbers, at symbols, and how to do some of the formatting. But if you look at like how this is laid out, this is highly particular, weird stuff. All right, let's just go back to it for a second here and look at some of the stuff they're doing. So normally you do like this, like search. So like we take the text, whatever that is, that's one of the parameters, and we're looking usually at these like weird little like caret symbols and periods and commas and dollar signs, and they all have a meaning. So in other words, we're searching to see if this phrase contains the word the and Spain. That's what it's doing, right? And I know enough about regex to read that into it. So does that, yes, we have a match. So in other words, yeah, that phrase contains the and the word Spain. If I change this to, that and ran it, then all of a sudden we're not going to have a match, right? No match. Right? So if you think about the data that you want incoming, then you can kind of qualify your statements. Now, what gets really weird is it has different functions. Typically, we're using the search function to do most of the work. And then it has this complex syntax. Once again, don't worry about memorizing it. Google what you need is what I always tell my students. But if you're looking for a set of characters within a certain range, right? Like if you want the whole alphabet, you go A to Z. If you want the capital letters, you go capital A to capital Z. And usually you want both, right? But you can get very, very particular about it, and how many times certain letter sequences appear and whatever. And you can see the documentation. And this is an abbreviated set of documentation. So very common stuff that you do see is like the 0 through 9 for numbers, uppercase, lowercase letters. That's a common expression too. Or if you're looking for certain symbols or want to exclude certain symbols, right? Like, so for example, like when you go to a website and you create a new user account and they ask you to type in a password and they say you have to have uppercase, lowercase, numbers, and at least one special character, that's handled by regular expressions typically, right? And they're not rewriting it in the native language. They're using regular expressions because the work's already been done, right? And it goes on, and you can like kind of read up on this to your heart's content, but we have the code that we need. I just want you to be aware of what it does, right? And chances are when you write other applications for other classes, regardless of language, and once again, like in the software or data or AI programs here, web programs, HTML uses regex, JavaScript uses it, C# uses it, Java uses it, databases use it. It goes on and on and on, and it's the same syntax. So the beauty is, once you know a little bit of regex, it works in all those environments, and often you're doing very similar tasks. And if you don't know how to put the statement together, you Google it, you find examples. That's what most people do. In the old days, we would have that 3-inch book from O'Reilly sitting on our bookshelf, and we'd like look through it and then hope we're writing the right code. That's how we used to do it, right? These days we have the internet, and some geek out there has it memorized, and there's a reference. All right, let's go back and start doing a little bit of coding. We are going to take a break soon if you're wondering. All right, so regular expressions are a way of creating patterns that search a string for a matching formatting. So we're going to import the library, then we're going to get user input and create regular expressions to test the following: 5 or more letters, 4 to 6 lowercase letters, and 2 numbers, right? Email to see if it's valid. So this one is a little complex, right? I've seen much simpler ones for email, but we'll use the one that's here. And you can use another source aside from the one provided above, but make sure to include a comment citing it if you do. So like if you find another example of how to validate email, and you can find ones that are much simpler than this, you can use it. That's fine by me. And all that should be put in the helper file and import the function to your program to test for valid email. Okay, so that creates a couple of things. Okay, so we have a couple of complexities here to deal with. First thing is let's create the lab file to get started. So we're going to say module 5 lab3.py. Right, so there's our file. We are already told that we're going to import the helper function that's going to deal with the email piece. We're going to build this one step at a time. So I want you to just kind of follow with me here. I'm still going to import regex though. So I'm just going to, at the very top, import RE. We have regex available. We're going to import our helper. And then we're going to import something we haven't created yet. So I'm going to call on it first and then go in and create it. And so we're going to say get email, right? So we're going to build that in the helper file, but it's one of the last things we're going to do, but I want to just type it in right now. What I'm going to do in the helper file so we don't get errors is I'm going to build the framework for the function to start with. So I'm just going to say define get email, parens, a colon, and then I'm just going to put in a pass statement just so it doesn't throw errors and underline. We're going to come back and build this though. That's going to be a separate step. Here's where we're going to start. And what I'm going to do with this is I'm going to put some stuff in the chat right now. I don't normally do this, but some of you might want to capture this as notes. So rather than have you type it from scratch, if you want to capture this and put it in a text file somewhere, I'm going to drop this code into my lab file here. These are all comments. And we'll talk about this a little bit. This kind of explains how some of the regex works, at least the stuff that we're worried about. And then we'll start building the other stuff. We're going to take a break before we start building, but let's look at the assertions. So first, we use a caret symbol to start the pattern. So it always starts, so the beginning of a regex expression always starts with a caret. The $sign signals the end, right? Start, end, right? Whenever we want to look for particular characters, we use square brackets. If we want lowercase letters, we use this expression. If we want uppercase, if we want both, notice they're inside the same set of square brackets. If we want to just do numbers, or how about upper, lowercase, and numbers? Right, sounds like a password thing. Yeah, so there you go. All alphanumeric is included, and that's the expression for it. Then we have these things called quantifiers, and notice the curly bracket says how many of the previous character selection do we want? So for example, if I want lowercase letters, I need at least 4, right? If I want 4 or more, 4 comma nothing. If I want 4, 5, or 6, so basically this is a range, right? Let's say at least 4 characters, but no more than 20, something like that for like a password. So I can go 4 comma 20. And we can have as many of these character selectors and quantifiers as we want. So you can get very particular. So if you want to make sure you have at least 2 uppercase letters, 6 lowercase letters, a number between 0 and 5, you know, you can get totally particular. And you can see why this is kind of like a thing and a whole separate thing to study. Right. All right. Here's the other comment that I'm going to drop in here, and I'm just dropping this in as information, right? So we're going to use the regular expression module. We already added it. Search is the method for regular X, and then we either return a match object, which is a true result, or a false. So we do the search with the expression. We check a snippet of text, for example, that was typed in or entered or already captured. We come back with the true or false, and then depending on the true or false. So like think it, like if a user was typing in a new password, right? You could make sure it matched the criteria, and if it returns a false, you have them enter it again. And if you were polite, you'd say like you need some of these, you need some of these, you need some of these. And this becomes a kind of a whole art. All right, we are going to pause and we're going to take a 5-minute break, folks. And I will see you at, let's call it 9:05. All right, we have a bunch of tasks we have to accomplish, and I just want to go back to that list. We're going to get some user input, and we're going to test each one of these things. So let's build a little input prompt here. And I'm just copy pasting this in, by the way. So we're just going to set up a variable prompt for 5 or more letters. And here's the comments I wrote last time I did this. So we're going to create this thing called is match, and this is going to be a variable, by the way, and that's going to hold the results, right? So it's either going to be true or false. That's going to be the output of it, and basically we say for our purposes we're going to treat it as a Boolean because that's how we're going to use it, because it will trigger one course of action or another. So I'm going to create that variable called is match. I'm going to build the regular expression search statement. So it's re.search parentheses. Then inside the parentheses, we're going to enter our pattern, right? So the first part's going to be, the first parameter is going to be the regular expression, a comma, and then what we're checking. What the thing we're checking is the user input. So that's really easy to put in. The regular expression gets entered inside a pair of double quotes. Remember, we start with a caret symbol and we end with a $sign. For whatever reason, that's what they came up with. This one I'm typing out manually, but most of them I'm going to copy paste, by the way. In between those two symbols, square brackets. And then what is it we're looking for? And so the prompt is 5 or more letters. Those could be uppercase, those could be lowercase. So we're going to say A to Z lowercase, A to Z uppercase. And it says 5 or more letters. So after the square brackets, but before that closing $sign, we put in the curly brackets, and inside there, the expression is 5, comma, blank, right? The blank meaning or more. We're not setting an upper limit. If I said 5 to 10 letters, then I would type 10 here. But it could be as many as they want, right? So then how do we know it worked or not? Well, just like the example on W3 schools, we're going to set up an if statement to basically test it. Here's the if statement I composed last time. Oops, no copy paste there. So say if is match, keeping in mind is match is going to be true or false, right? So if it matches, we'll re-output the content and say it's a match. Otherwise, we'll say it's not a match. Right? I think we should test this, right? This is a very simple expression, but we'll give it a run. And you guys are still typing, so I'll scroll it up to the top so you can still see it. Control S to save. Here's the run. And it's giving me an error. So let's see what our error is. Did I never oh, yeah, it can't import the get email thing. You know what? Let's comment that out. Oh, I know why. I never hit save. Okay, so I got to hit save on my helper file. Let's try the run again. Here's the run. And yes, I will scroll so you can see the code. Oh. Okay, so 5 or more letters. So I'm going to type 4 letters. Not a match. Okay, run it again. We could have a loop on this, so we need to type it. Type in some numbers. Okay, not a match. Let's do 5 letters with 1 uppercase. That's a match. Let's do some lowers, some uppers. And let's make it really, really long. And that's a match. So this is working, right? 5 or more characters, upper or lowercase. Everybody okay? Let's move on to the next tidbit. And that is we need to do a prompt asking for 4 to 6 lowercase letters followed by 2 numbers. So once again, we're going to use the is match and the search. Paste that part in. Parentheses. We're going to check the user input again. So this is kind of weird to type it in backwards, but this is how my brain works sometimes. Put in our double quotes. Once again, caret symbol to start, $sign to end. And then let's get our patterns inside here. So inside of square brackets, we want lowercase letters, no uppercase ones this time. And we want 4 to 6 of them. So inside curly brackets, we do 4, 6. That establishes the range, upper and lower part of the range. Then we want numbers. So now separate square brackets, and inside there, we'll say 0 to 9, any of the 10 digits of the numbers. And we want exactly 2 numbers. So here's the curly brackets, and there's not going to be 2 comma or 2 comma something. It's just 2, exactly 2, no more, no less. And I know you guys are still typing, so I'll leave that on the screen. We'll run this again. So it still wants the 5 or more letters. Let's just give it 5 letters. Are we done? Now it wants 4 to 6 lowercase letters followed by 2 numbers. So I'm just going to do 4 letters, 2 numbers. Okay, well, we didn't put in an if statement to test it. Oh, okay. All right, well, that's easy enough. So let's copy that same code, same if statement, paste it back in. Let's try that one more time. So 5 or more letters. Okay, that was okay. Now 4 letters, 2 numbers. That's a match. Let's run it again. And let's try to break it this time. Let's give it something that's incorrect. Let's give it an uppercase letter and 3 numbers. And now we have not a match.
Are we replacing the variables user input and is match every time we run, like the 2 times we replace a command? Or
Yeah,
we do the command?
in this case, we are, because this is very much a test. You know, we're not really using it for a functional purpose. We're just showing how the reg expression feature works, right? But
Okay.
if I was writing a real application, I probably wouldn't do it like this way. This is just to show proof of concept that the
Okay.
input that we're grabbing is being validated correctly. You could see very quickly how you could apply this to, like, password validation scripts, like a minimum number of characters, upper lowercase numbers, et cetera, et cetera. Right? You could easily enforce a pattern with this. And the thing about regular expressions is they're highly flexible, so you can kind of apply them to a lot of different situations, and you can basically adjust the whole construct to kind of deal with it. The last part of this is to do an email thing, right? And that's that thing that we haven't built yet in the helper file. But what I'm going to do here at the bottom is I'm going to call it. So I'm going to call get email, right? Even though I don't know what's going to go into it right now. Like, basically, we're going to do something like this. Enter a valid email address. So we're prompting, basically. This is text, though, so keep in mind what's happening here. This is text that's going to get sent to the function in the helper file, and that's going to process it. So I'm going to save my work here. Now I'm going over to the helper file, and I'm going to build the correct code in the helper file. This is where we copy the code that's given, by the way, but let's set this up first. So the first thing that we're going to do is we're going to pass information in. So whatever that information is, you can call it whatever you want. Last time I called it prompt, so I'm just going to do that. Okay. So, and here's the why, right? So first I'm going to start a while loop, force it to run. So while loop set to true. Inside here, we're going to set up a variable called email. We'll prompt with the text that was sent in. So enter a valid email address. Is that what it's going to say? Capture the text stored in an email variable. Then we're going to use that same is match variable name. That seems like a good one. We'll run the regular expression search function. And we have this really long expression. And I don't want you to type that in manually because there's so many little nuances to it. Right? If you look at it really carefully, one character off and the whole thing can break, or it doesn't work quite right. So you do want to copy paste it. So what I'm going to do is the whole statement I'm about to type in, basically whatever goes in between the parentheses, I'm dropping in the chat window for you guys, so you guys can just copy paste it in. It's in the module on Canvas anyhow, right? So you can copy it from there. So here's the expression. I'm pasting it in between my parentheses, and man, that goes like off the edge of the screen. Keep in mind that you can turn on word wrap on the view menu, and you can see it all in one spot. I want you to notice what's happening here, though. You notice how the regular expression thing is going, that I can't find that. Well, the helper file needs to import the regular expression too. So at the top of the helper file, I'm going to import RE, if you want to, importing regex. So don't forget to put that at the top of the helper file. Otherwise, this will underline and it won't work. Right? Import RE is all you have to put at the top. So now that we have the expression in there that's going to be tested, we can run kind of the same if else statement, and I'm saying kind of the same, right? Here's the difference though. We'll say if it's a match, they typed in a valid email address, we just send the email address back and we use it in our code. If it's not valid, you ask them to enter it again. Okay, so the loop will keep running until they put in a valid email address. Now you could throw counters and stuff in here too to pop them out at some point, like give them like 5 tries. And if they can't get it in 5 tries, chances are they're never going to get it, right? But if you were to backwards engineer this statement, and I want you to notice there's quirks to this one, right? This gets pretty complex. So you'll notice letters, numbers, those are okay in an email address. The exclamation point stands for not special characters. You notice all these weird special characters in here, right? And then it has these little sub expressions, including pipes, curly brackets, tildes, dashes, underscores, reverse apostrophes, et cetera, et cetera, et cetera, et cetera. All that's disallowed. And it has to have all of this stuff. And I think the way the syntax works is after. So in other words, you can have characters and numbers, a period's allowed in the first part of an email address. And once again, all the same stuff, but not the special characters again, right? I don't want to move that. Then it looks for the @ symbol. Then after the @ symbol, it looks for letters and numbers again. Those can be part of the first part of the domain name. And then at some point, it's looking for the period. I can't break down all this, but I'm getting pretty close. And then after the period, letters and numbers again, whatever defines the top level domain. This is a pretty specific one. I would speculate, and I'm just going to kind of do this really quick just to show you. So I'm just going to bring up a little helper here. See what it comes up with. I'm just really curious. A lot simpler. So if you were to go out there and find one like this, you would be free to use it. This would probably work just fine. And most of the ones that I've seen, by the way, are simpler like this because some of the rules have changed a little bit for the regular expressions of emails. They get kind of particular. And one of the parts that I'm seeing that I'm agreeing with is like, and I don't know if this is present in ours, but I think after like the @ symbol, you can say like whatever dot com or whatever. That can't contain numbers, but the domain name can, as long as it doesn't start with a number. It's like it's all goofy like that. But there are rules. So like if you wanted, you could experiment with this expression and just drop that in. Or if you find a different one, you could just drop it in. Right. That's kind of the point of that example, really. All right. Now that we have it built into the helper function is saved. I can go back to the lab file now and we can run that statement. So let's just, well, we have to get past the other one. So 5 or more letters. Okay. 4 to 6 lowercase 2 numbers. Okay. Now a valid email address. Let's try to break it, right? So let's just type a bunch of weird special characters. Well, there's a couple of @ signs there, so we'll see what happens. And then we'll do this dot. Okay, so it's prompting me again. So let's just do some letters, an @ symbol, some letters, dot, some letters. That's valid. Notice we didn't get a result from that. It just took it and ran with it. And so the point is that we are checking for or asking for a valid email address. It's getting it. We're not doing anything with it, right? At this point, it's just running, but not actually being used for anything. If we wanted, for example, we could add just a little piece here, like a variable, call it like, I don't know, user email, store it, and then print it. Okay, so let's just run it one more time. So 5 or more letters, 4 letters, 2 numbers.
You put user input rather than user email.
Ah, thank you. Yeah, so yeah, it's going to fail. It'll capture it just fine, but it'll give me what I typed before. Okay, let me fix that. Thank you for catching that. Okay, let's save it and run it again. All right, 5 or more letters. Letters, 2 numbers. There we go. So now it's working. But you can see why this is useful, right? So if you have a program where you're prompting somebody for an email address and you have a script that works correctly. Now, of course, this is very minimal testing. Like I would test a whole bunch of different scenarios, and then I would kind of adjust from there. I'm going to pause the recording here for just a moment. All right, moving on to Module 5, Lab 4, where we're going to utilize kind of a combination of all the skills we've learned so far to build something a little bit deeper. Let's look at the description here that looks like a bunch of bullet points here. So let's kind of read through them really fast. We're going to create a dictionary of roles and descriptions as follows. Administrator, right? Instructor and student. So these are academically based. So we have people that are administrators, people that are instructors, and people that are students. We have a stakeholder class with the following properties. So in other words, the data fields. The data fields are going to be first name, last name, email, and which one of those roles they take. Now, keep in mind the roles are going to be stored in a dictionary. Also, we're going to have methods. We're going to have our init method. We're going to have our string method. And then we also will have another method. We haven't really added a lot of methods to our classes so far, but this is going to be a method that does something that gets the role description. And I want you to look at that keyword get. That means it's retrieving information from specific aspects of the data structure. It says create a menu with the following things. looks familiar, right? So we have all the basic CRUD operations, list, add, okay, list stakeholder, add stakeholder, list role, add role. So we're working across two data structures here. That's kind of interesting. And then an exit option. And then we're going to do validation on first and last name so that they're letters only. And the email piece, which we've already done, we have that built into our helper function. So all we have to do is utilize it. So see how useful that is. Like once you have it built and you have your own little helper library of functions that you're using, now you just bring it over to your new program and utilize it and roll with it. You don't have to rewrite it, right? And that concept is a really important one in programming, and that is, creating modules that can be reused or objects that can be reused, right? And when we work with other people's APIs, like we were talking about how a lot of AI development really uses open source pre-built libraries, all you have to do is learn the syntax of how to use it, and you're up and running. You just import it, figure out the syntax, test it a little bit, and then, oh my God, you can have incredible functionality without a lot of effort. Right? Still have to get the concepts though, and we're still working on those concepts. Right, here's example output. Right, so we're going to do all these things. All right, so we'll come back and look at that when we need to, but let's start with the basics here and start building this piece by piece. All right. I'm looking at a couple different things here, and the first thing I'm looking at in my solution file is we might have to add some stuff to our helper file to help us out in the process of this, right? So right now in the helper file, we're importing regex. We have a getInt function, a getInt in a range, right? We've utilized these over and over. Now we have a get email. We've seen how that works, and that'll be really easy when we get to that piece. But there's the other piece that we didn't think about yet, which is when people type in their names, we need to be able to validate that they're just typing letters. Now I could write a regular expression like this right in the main body of my code, but if you think about it, when they enter their first name, we're checking to see if the letters are right. When they're entering their last name, we're checking to see if it's letters, etc. So anytime somebody is being asked to enter text, we can use a function here that we create to just make sure, are they letters? See where I'm going with that? So let's build this other function in here, and then we don't have to write the code over and over again in the main application. So I'm going to do a def, and I'm going to call it get letters. Right? We are going to send in information, and that's going to be the prompt that's put on the screen to get them to enter the info. Then we'll capture it here, make sure it's valid, and if it's valid, send it back. Like all the other code inside this helper file, we are going to start with basically a while loop that just forced to run. So while true, spelled correctly. Okay. Same thing that we did before. We're going to check the user input. So I'm going to call my variable user input because that's what I called it last time. And we're going to prompt with the text that was sent in to the helper file. Okay. From there, we're going to do the isMatch thing. So we're going to, let's just copy the very first part of this regular expression, because that's how it's going to start. We'll close the parentheses, and then we'll put the expression inside. So the ask is, like, if somebody is going to, we want them to type letters. Okay, that could be uppercase, lowercase, and at least one letter, right? So like most, and I guess, can you think of anybody who's got a name that's only one letter long? Maybe not, but there are people that go by initials, right? Like I can think of a few. All right, so this will actually be a pretty simple expression. So double quotes to start, caret symbol, and dollar sign, right? So I always, when I do regular expressions, I always do that pattern. Quotes, caret, dollar, and then I put everything in between. We want letters, so square brackets. We want A to Z, all lowercase, then A to Z, all uppercase, and we want at least one letter. Now, if you wanted, okay, so for example, and anybody who does like sysadmin work will know this. Like, if you ask somebody to create an account name on a system, like on a Unix or Linux system, typically, or a web-based system, usually they want the username to be at least X number of characters. I think that the typical is 6, right? If it's less than 6, then you're adding stuff to it. We also, if we're asking for letters, we don't want to allow numbers. So numbers aren't part of the mix here, right? Just letters, upper or lowercase is all we're accepting, right? What are we checking? We're checking the user input. And then we're just going to do a simple if statement, right? If it's a match, we return the letters back to the program and the program uses them. If it's not a match, we give them an error message and it's in a while loop. So it's just going to keep prompting until they put it in correctly. You guys are typing this one here, so I'll give you a second. Hopefully you're getting smart and screen capturing it. I could just be really nice. It's the end of the night. Put it in the chat, right? So Anthony, you know, since you've got a class with me before, right? In C# we were writing so much code sometimes that this is the only way we could kind of get through the labs, is I would just type it up and share it.
Very true. Very true.
And you know what? There's nuances to this too. Like, you don't want to like mistype it, right? Because then that like slows you down even more. But I think you guys see the pattern of this now, right? How this is useful, right? And so now we're adding this other functionality. Don't forget to save. Remember last time I forgot to save this, so Control S to save. Let's make sure. There we go. So change from circle to an X. Now let's build the lab file. So I'm going to come over here, create a new file. We'll say module 5 lab4.py. And we're going to need to start with imports. All right, here's the question. Given all the information we read on the other page, will I be checking any RegEx stuff directly from this file? Here's the answer. No. The helper file is going to call the RegEx. But I do want to call in the helper file. So let's do from, oops, wrong screen. If I had $1, right? So from helper, import, well, I could import everything. Which of the things do I know I'm going to use for sure, though? So this is, and I'm showing you this, you know, just so you get the syntax of it. So I could just do this, right? Bring in everything. But there's one, you know, that first function that we wrote, get int, we're probably not going to use it. So it's not wise to call in stuff that you're not going to use because it burdens memory and slows you down. But we'll use get email, we'll use get int in range, and the new one that we just created called get letters. And you notice how we're in a different file, but it's in the same folder and it's finding it and it's pulling it up on the list as I'm typing it, which means they're talking, the files are talking to each other, right? They're connected, right? And we started with this topic earlier tonight, and Alexis, you posed a great question, right? It's like, well, does it have to go in the same folder? Well, if you want all the stuff to travel together nicely, package it up and deliver it to somebody, that's how Python works. Yeah, you would want it there. But you could also add it to your main Python libraries, right? For sure. All right. Next thing is we want to build a dictionary of the roles. Okay. So I'm going to create roles underscore descriptions is what I'm calling it. I'm just making sure I'm spelling it correctly. Roles underscore descriptions. And that's going to be a dictionary. So curly brackets. And then I'm going to split it. And then what they're really asking us to put inside here is the stuff that we saw in the lab description. I'm just going to go back there for a second, is basically this text. That's our dictionary. These are the keys, you know, right? Those are the keys. And then these are the values. So you could just copy paste it, structure it like a dictionary entry with double quotes, colons, commas in between. Or you can just wait for me to paste it into the chat, which I'm going to do. Right. Because you'd be copy pasting it anyhow. Right. And then tweaking it. Let's save the time so we can get out of here in a timely fashion tonight. Right. So I'm going to paste that into my code. So right in between those curly brackets comes that code. And once again, I'm turning on word wrap because I'm going off the edge of the screen. But administrator is our key. This is the description for our value. Comma to separate, but we have administrator, instructor, and student, and it describes what they are. You can imagine if you wanted to add additional roles like staff, adjunct instructor like me, right? Or student wannabe, graduate, alumni, whatever. You can have all sorts of roles that you could define in here. It's really kind of in your mind's eye. We are asked to use a class structure, and the thing that we were asked to build was a class called stakeholder. And I did this last time with a capital H in the middle, so I better follow suit if I copy my code, right? So the class definition is stakeholder, capital S, capital H. We are going to build an init function, 2 underscores init, 2 underscores parens, a colon inside the parens will have the self-referring. And then we were told that we want to capture the first name, last name, email, and their role, right? So, and I'm just going to let you guys know, if you guys want to pause on typing, I am going to paste this stuff in, right? So Anthony, I think, feels where I'm going with this because we're kind of in the same boat. We're kind of tight on time, but we should be able to get it in if I help you guys out. And so I'm going to get it all in place here, and then I'm just going to drop it in the chat as one chunk. And now you guys are saying to yourselves, why weren't you doing this all along? Because there's value in typing it and getting the feel of doing it right and wrong and seeing how the tools work is the answer. But now that we get these concepts, a lot of the concepts are, I don't know if you're picking it up, are repeating. So let's accelerate our workflow here a little bit. All right, next, we're going to put together a string function. And you know what? Let's really put it into overdrive mode here. I don't know why that one came across bold, but it did. Right? Does it come in bold for you guys in the chat? That's weird. I didn't even know I could do that in the chat. All right. So this is the string function. It just takes all the data and outputs it. I have it already formatted. There's line returns, tabs, and all that. It is also calling, I don't know if you're catching this, another function within the class that I haven't even built yet. And we're about to build it. So the next one is called get role description. So once again, I'm going to drop this in the chat, and then we'll talk about what it does. Right. So what this does when called is if the role and roles descriptions, if there's a role defined, that's what this is saying. There's a role defined in our dictionary of roles, or is it our class? No, it's dictionary of roles. Then we'll return that role back to the program and utilize it. Right. That includes the string output. Isn't that interesting? So when we do our string output, instead of like reaching into this other structure, we're having this function do it for us because it has some error handling built in. So if it exists, we'll return it. If it doesn't, it won't. Right. And if you have a role that doesn't exist, now keep in mind, when we build the program, we are going to have the capability of adding roles and adding what is it, descriptions, I think, right? stakeholders and roles, right? So we can list them and add them. Notice we can't take any away, but that could be easily added. Okay, so this is our class definition. Now we need to create a list of stakeholders, right? So this is kind of a repeating process here. So the singular class is called stakeholder because it defines one. The list that will contain the stakeholders is plural and lowercase. So stakeholders, square brackets, split your square brackets, and then we'll put in a number of stakeholder objects. And I'm going to do you guys a solid, so I apologize I didn't do this before. If you were waiting, right, because I think you've been waiting. Now I got you spoiled, right? Carrot on a stick, right? All right, and I'm going to do the same with my list of stakeholders. It's in the chat. All you have to do is pop the whole thing in. You can tell I borrowed this code from Patrick, by the way. So any of you that study with Patrick, he originally wrote this code and I just tweaked it. And these are people, Rich Barnhouse is, I think, the college president or something like that, or CEO or whatever they call it there. Patrick obviously is an instructor. And then we have Jane Doe, a anonymous student. Right. If you wish, you want to add yourself, you want to add one of your other instructors, you can do that. Right, now let's get to the running of the application. We're going to start with our big while loop at the bottom. This is our normal pattern now, right? This is how we keep our programs running. So we say while true, colon, and up comes our menu. And saving you time here, folks. Now, by sharing code with you, I just want to let you know I'm doing a 10-point rebate. I'm taking back 10 points because you're copy pasting my code. I'm kidding. But this is a lab exercise, right? The point of this is to get it to work and to see how it works so that when you're doing that assignment for this module, keeping in mind the assignment for this module is due almost at the same time the next module is due because the course is ending. So we have that pressure as well. Next, we'll capture the choice. We'll put it over to the get int in range function. And then we will write our if statement at the bottom, which is not in the chat. So here comes if statements. And we're going to build these functions now. So we're going to build 4 functions. List stakeholder, add stakeholder, list roles, add roles. And at this point, conceptualize this, like when you move on to the assignment. You have the skills available to you now, just from example in our labs, to also remove them and update them, all of these. Maybe, well, I don't know if we did updates on dictionary, but that's not very hard to do. All right, let's build them one at a time. So let's do list stakeholders. Print a blank line. So for each stakeholder in the stakeholders list, we'll put them on screen. Done, right? Very simple. To add a stakeholder, let's get a blank line. Notice here we're using our new function. We're prompting get letters. So we're saying first name and make sure letters are entered, no numbers, right? Okay. Of course, if we get the artist formerly known as Prince who puts in a symbol, then we really got problems, right? You better type out his old name. So we're doing that for, notice get letters for first and last name. For email, we're using our already built get email regex driven function, which not only will capture it, but make sure it's in the right format, right? And imagine, right? Anybody who's a database person, and if you haven't been yet or about to study it, databases are highly particular about how information is entered. Python doesn't care, right? You can enter whatever you want in Python, not in a database. That doesn't work. Then we'll have them input their role. We'll capture that, and then we'll do an append to the stakeholders list. The role will be added to the end. And of course, in an ideal world, we would say, it's got to be one of these roles, but we know what the roles are, right? Administrator, student, instructor, right? That's what it is. Moving on to the next function, we're doing a list of roles. As you can imagine, that's very similar to what we just did. But now we're dealing with a different data structure, right? What's the data structure we're dealing with? We're dealing with dictionary key value pair, and we're pulling back both the role and the description from the role descriptions dictionary, listing them as a list of tuples, right? That's technically what the items things does, and then we can very easily output them. Something we already did. And then finally, our last function, which is add role. Once again, blank line, prompt them for their role, or excuse me, the new role that we're adding. And I mean, if you wanted to be particular about it, you could say new role, new description, I suppose, right? So I don't know what role you would think of. You could, staff, I think, adjunct, alumni, whatever, thinking academically. And then after that's entered, the role goes into the key, the description goes into the value, and this is enough to create it right there. That's pretty slick, actually. And then if you wanted to do an update on a dictionary, by the way, you would just declare here the name of the key, whether it's a number or a string, and then just put your change here and it would store, which is pretty slick. So we're not far away from doing update. The big question is, how do you do remove? Well, we did that too, didn't we? That's a pop, right? Yeah, not too bad. And then when we're all done, we list it so we can see it. And we kind of didn't do that with the stakeholders, did we? So how do we do that? We list stakeholders. Oh, I think there's a reason why okay, you know what? I'm going to do it anyhow. So add that in. Not hard to do. All right, folks, let's go ahead and give this a run and see if it works. All right, so we're going to do this one at a time. I'm going to start by first, and you notice how those extra lines at the top kind of help. And you know what? Our programs are starting to look a little nicer now too. I think I could fix that options thing at the top a little bit. Starting to look like something here. All right, so let's just do the listing first. Let's see what's in there. So let's list the stakeholders. Okay. Notice pretty nice layout, right? Got the name, the role, email address, and then the description for the role underneath. And notice we're going last name, first name. All right, let's list the roles. There's the 3 roles. All right, so let's just add a stakeholder here. So let's do option number 2. And feel free to enter yourself. Try to break it by putting in a number. Okay. Put in a nonsense email address. I should probably try to make it look real, right? Here. And my role would be instructor. And there you see me added to the list. Looks pretty good. Okay. Let's go ahead and add a role. So I'm going to type in a new role. And what's the role that we want to put in here? Staff. New description. This person does stuff at WCTC. Like shovel snow. I'm stretching. But maybe they plow the parking lot. Now we can see that's added. So now I can add a new stakeholder. Right, we'll just call him John, whatever. His email is J whatever at wctc.edu. His role is staff, and there he is added to our list. Now, there's a bunch of things we could do to make this look better, add functionality to it, but I want you to pick up on all the different components that we've added here. This is a lot of stuff that we've added here tonight. We've started working with regular expressions. We're working with a new data structure called a dictionary. We're also starting to use tuples to sort of do stuff in the background. We're working with class structures, function-driven programs, programs that keep running, being able to add data and add it to two different data structures, right? And then have those two data structures talk to each other, basically. So we got a lot of functionality built into this. So when you step into the assignment, you have a great head start here on the approaches that we're going to use to kind of do that assignment. Remember, we'll cover the solution for the assignment when we start next week. Next week, we also have to get through all the labs and try to do the assignment during class time. So the copy paste mode will probably continue next week because it's probably the only way we can get it all done. All right, folks, this video will end here.